Is this a clickbait title? Well, not quite. The 96.8% is here, and the newest Supersprint pump is better than every single one of them. 1 month ago, I said this.
Therefore, in the next days, I will take a look at the Supersprint pump design if there can be any changes which would lead to decrease in power consumption while not sacrificing too much of the performance.
To achieve that, I tested 31 design iterations of the Supersprint pump. In this video, I will show you how that went and which change finally led to the improvement. I will also compare the performance of the newest improved Supersprint pump to the old one. So, about the process, where do we even start? The Supersprint pump has 3 parts: the intake, the pump, and the impeller. Because we are using the static thrust test for the optimization, which means that the boat is not moving, we cannot optimize the intake by using this method. Because the situation during the measurement is completely different compared to when the boat is running on the lake. Of course, for optimizing the pump and the impeller, the static thrust test is still not completely accurate to the reality of the running boat, but it is close enough for us to use this method for comparative tests between different pumps and different impellers. Let's first talk about how the pump can be optimized. I can change various dimensions of the internal geometry of the pump. For example, increasing the length of the vanes, changing the angle of the vanes, changing the number of the vanes, changing the conical mixed flow shape which the pump has, changing the outlet diameter, and even change the conceptual geometry completely, resulting, for example, in this alien-looking two-path nozzle. Which, by the way, is complete crap. So I tried all of those changes and I changed the parameters which I named back and forth to find the best combination. And you wouldn't guess what happened. After testing 16 of these various pump changes, none of them performed better than the original one. Which was kind of funny and kind of demotivating, but the reason is very simple. I did all of this optimization on the MJ35, and the first version of the Supersprint pump was basically a scaled down version of the MJ35, which was therefore already optimized. Anyway, it was useful for the verification that the chosen parameters were correct. Let's move on to optimization of the impeller. Various parts can be changed on the impeller. Length of the blades of the second stage and of the first stage. Pitch of the second stage compared to the pitch of the first stage. First I tested these two changes and they also didn't bring any improvement to the existing design. But after trying that, I finally found the key parameter which wasn't optimized yet, and that's the progressive pitch. Since the development of the MJ35, the MJ pumps have progressive pitch. This means that the pitch of the end of the blade is higher than the pitch of the start of the blade. The goal is that the water approaches the blades of the impeller at the perfect angle parallel to the start of the blade, and it also has to leave the blade perfectly parallel to the end of the blade. Because of the impeller rotation, as the water passes by, the impeller gives some of the rotation to the incoming water, resulting in a swirl in the area of the end of the blade. This is, by the way, why we need the stator vanes to balance out that swirl from the impeller. So because there is no swirl at the start of the blade, but there is swirl at the end of the blade, the situation on the start of the blade and the end of the blade is different. And this is why the pitch on the start of the blade has to be lower than the pitch on the end of the blade. So just by finding the correct values for the start of the pitch and the end of the pitch, I was finally able to improve the performance of the Supersprint pump in the desired way. And now let's take a look at the measurements. First, for comparison, let's take a look at the measurement which we did 1 month ago with the first version of the Supersprint pump. This was the old measurement, and now the new measurement of the Supersprint pump just with the updated impeller pitch. So what you just saw is the best optimization I was able to achieve with the Supersprint pump just by changing the geometry. After optimizing the geometry, there was one last trick left, and that is improving the surfaces on the pump. This was tested and discussed with Ryan Frere. Shoutouts to you and thanks. So I smoothed the parts using acetone, and this is the measurement I got. And now this is the acetone smooth part. And there is still some roughness present. I wasn't able to get that off, but especially near the end, where the nozzle is, the surface is much better. It becomes quite smooth. And probably if you spend some more work on it, it will become even better. Now, you need to be careful about the technique of the smoothing you choose, because at first I chose to vapor smooth it. This is the result. And I overdid it, which screwed up the mounting point, which caused the pump to be mounted offset from the center, which worsens the performance by about 2 kilos of thrust. So you really need to be careful to smooth out the inside, but not deform the mounting point. And therefore, what seems to be the better method is to use a brush and brush the acetone into the inside of the pump. And you have to do this multiple times, but eventually you will get better surface than you had before. Now let's compare the data we got, and also compare it to the original MJet Sprint. So first of all, we are getting a nice little increase in thrust, even though the main goal was to optimize power consumption. This is a nice little bonus, which will make the boat accelerate faster. But as I said, the main goal was to optimize the power consumption, and that, as we can see, was highly successful. The power consumption of the newest Supersprint pump is even a tiny bit lower than the consumption of the single blade impellers in the original MJet Sprint. This means that with the newest Supersprint version, you will get the same or even better runtime than with the single blade impeller mode on the Sprint when using the same electronics. And where do these savings come from? So the savings come simply from wasting less power in the pump, thanks to improving its efficiency. If we use the original MJet Sprint with a 3-blade impeller as a baseline, we can see that the efficiency of the latest acetone-smoothed newest Supersprint pump is almost 2 times bigger. I am happy to say that I am calling the optimization of the Supersprint pump finished, because this is the best I can do. And now as I am talking, the improved Supersprint pump is already available for download as version 0.4. You can print the new impeller and enjoy a little bit of edit runtime. Together with the Supersprint version 0.4, there is also one more little but important improvement to the lid. The lid base now has a different geometry, which makes the lid easier to insert while preserving the seal, and this geometry was designed by Lenny B FPV, link to his channel in the description. So thank you very much for that. For the next Supersprint version, I will take a look at what we can do to design a new scale engine for the boat, so stay tuned for that. And for now, go and make your boat fly.